All right, today's date is 11/12/19. Okay, so today what we're doing is solving rational equations. And again, rational means fraction, okay? So my sophomores, when you take the SBA test, they ask this all the time. They say, which numbers are rational numbers, okay? So hopefully by the time I've talked to you for like the last 2 weeks, you know they're rational. You see rational, what is it, Parker? There you go. You're going to ace that, aren't you, right? So, take a look. Now, in number one, before we do anything, let's talk about this. Don't divide by 0, okay? So sometimes you get answers. For example, if I went through and solved this whole problem, and I got x equals -8, okay? Just go with me. We are going to solve. Let's say I do all the math, blah, 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 and I get x equals -8. You're not going to keep that answer. You're going to throw that answer out. Why can x not equal -8 here?
Because it would make the denominator 0.
Right, it would make the denominator 0, right? And the same thing with this, if it's 3.5, and we talked about that, then you can't keep 3.5 either because it makes the denominator 0. So there's two things. Before I even solve it, I know that x cannot equal -8 and x cannot equal 3.5. Okay, so before I even start, okay, what are the excluded values? Well, x cannot equal -8 and x cannot equal 3.5. Now where to get the 3.5 from? I'm going to show you here in a second, okay? I know that the bottom can't equal 0, so if I cheat and make it equal to 0, I can find out what it shouldn't be, because this one's not so easy to say, but let's say I said, well, okay, 2x minus 7 should not equal 0, right? Now, this should not equal 0. So if I set the bottom or the denominator equal to 0 and solve, add 7, divide by 2, 7 divided by 2 is 3.5. So x better not be 3.5 because that's a value that makes it equal 0. So these are the two things it cannot be. That's not the answer, but when I do the math and I get that answer, throw it away, okay? All right. If you get a fraction equal to a fraction, cross multiply. The reason it works, the reason cross multiplication works is if you multiply by, I'll just show it, okay? Real quick, because it's easy. If I multiply by 2x minus 7 on both sides, right, it would cancel. And if I multiply by x plus 8 on both sides, right, then it would cancel, right? And what it really did basically is the 2x plus 8 wound up here, and the 2x minus 7 wound up here. Okay, so now let's not do it that way. Let's do it easy. Easy. So the easy way is this. You have a fraction equal to a fraction, cross multiply. Show it again. If you got a fraction equal to a fraction, cross multiply. Okay, I'll show you what I mean. This denominator, 2x minus 8, I'm going to multiply up here, cross multiply. This 2x minus 7, cross multiply, bring it up here. And when you cross multiply, the fraction disappears. It's just gone. So I will have 2x minus 7 times the 2 equals my 5 times my x plus 8, okay? I just cross multiplied. Only works on a fraction equal to a fraction, but that's pretty easy. And now we're just going to solve. I can do that. I'm going to distribute and get a 4x minus 14 equals a 5x. Yes, I did that on purpose, didn't I? And then from there, we're just going to solve. Minus 4x minus 4x. I've got a negative 14 equals a 1x plus 40. This one is on, it did. Minus 40 minus 40. I get a negative 54 equals x. What x can't be is -8 or 3.5. I'm good. That's a good answer. Okay? Thumbs up? Okay, that was not too bad, right? Okay, example 2. In example 2, before I even start, x better not be 3 and x better not be 6. Okay, number 2, if x is 3, we divide by 0. If x is 6, we divide by 0. You cannot divide by 0. So before I even start. Now, same thing. If you have a fraction equal to a fraction, we're just going to cross multiply. So I'm going to take the x minus 3 and multiply it up here, and take my x minus 6 and multiply it up here. So when I cross multiply, the fraction goes away. So I'll have an x plus 1 times an x minus 6 equals an x minus 3 times an x plus 2. How am I doing? Okay?
Does it matter which place the fractions go to? So it could be x minus 3 in parentheses and then x plus 2, or does it?
It doesn't matter. You're right. Because you can multiply in either order. Really good question. Okay? So then, this is also on our warm-up, right? We're just going to FOIL it. Okay, ready? X squared. This is the one Autumn did, minus 6x plus 1x minus 6. Okay? If I FOIL the first fraction, or the first product. The second one, if I FOIL, I get an x squared plus a 2x minus a 3x minus a 6. Okay? Okay, just FOILed or multiplied through both sides. Okay, let me rewrite this as an x squared minus a 5x minus a 6 because I combined those two, right? This is going to be equal to an x squared minus a 1x minus a 6 because I combined those two x's, right? I'm still solving for x, so what I notice is x squared, right? And so if I just subtract x squared from both sides, if I minus x squared from both sides minus x squared from both sides, they disappear, right? They're gone. Cancel. I like that. So now I don't have to worry about factoring or anything like that. I just got it, right? Now, minus 5x minus 6 equals a negative 1x minus 6, right? Am I going too fast? I'll wait for you. So now let's just solve for x. Okay, Austin, I think, is this one you did? Yeah. So then I'm going to go plus 5x plus 5x. I'll skip a step and go plus 6 because I'm running out of room. I'll just do 2 steps at once, but we're in Algebra 2. I can do that. So I have 0 equals 4x. Divide by 4, and x is 0. Now x is 0 is okay. We just said x couldn't be 3 or 6. X equals 0 is a good answer. 0 is a number, so it can be an answer, right? Okay, thumbs up. Okay, turn the page. Now, example 3. Before I start, I know that x cannot equal negative 1, and x cannot equal negative 2. You guys okay with that? There we go, screwed it up, sorry about that. X cannot equal negative 1, and x cannot equal negative 2. Now before we start, I'm going to need a common denominator to add these two. I can't just quickly cross multiply, but I've got to be able to add these two fractions here, okay? So the first thing I'm going to do is get a common denominator between those two, okay? So the common denominator is to multiply this one by, what does this one have? This one doesn't. An x plus 2 and an x plus 1. So before I even start, multiply this by an x plus 1. I'm sorry, x plus 2, x plus 2, and I'll multiply this one by an x plus 1, x plus 1. How's that going to help me? Well, these two are going to have a common denominator of a x plus 1 times an x plus 2, okay? Okay, so if I'm going to add fractions, I have to have a common denominator, okay? So, but the common denominator is x plus 1, x plus 2, okay? Now I'm going to simplify. 3x plus 6 plus a 4x plus 4. Man, that was a lot of work for a 7x plus 10 over an x plus 1, x plus 2. Okay, how am I doing? And that's going to equal my 15 over my x plus 2. How am I doing? Now, if I cross multiply, it's going to be a pretty big problem, okay? But I've got another trick that's going to help, okay? Another trick, okay? So let me get a common denominator here also. So now I'm going to make a little note. I want to get a common denominator. So I'm going to multiply this one by an x plus 1 over an x plus 1. How's that going to help? You're like, why are you doing that, Mr. Davies? Why are you doing that? You're just making the problem harder, right? But you don't like fractions, do you? So I'm going to do a trick, and I'm not going to write it on the paper, but I'm going to write it on the board, okay? So nobody likes fractions, right? Just watch this. Just listen. I multiply this side by, you ready? X plus 1 times x plus 2 over 1, okay? And again, what you have to do on one side of the equation, you kind of do the exact same thing. Okay, it seems like I'm doing a lot of extra work, doesn't it? It says, why are you doing this? So let's do the same thing. X plus 1, x plus 2 over 1. Looks like I'm making it huge and ugly, but what am I really doing? Anybody see it? Says John? Sorry, John. What am I going to, yes, what am I canceling? Check it out. All of that cancels all that, right? And all of this cancels all of that. So if you can get a common denominator for both fractions, you can just cancel it out. So what are we left with? 7x plus 10 equals 15 times x plus 1.
15x plus 15.
And then it becomes an easy problem, doesn't it? Okay, one more time before I move on. You can get a common denominator on both sides. And then if you multiply by the common denominator, so what I'm going to teach is this. Okay, do you mind if I erase this? Okay, now that's the y, and here I'm going to tell you. Okay, listen to what I'm going to say. Okay, so what's what I'm saying? If you can get to this point, you got a common denominator, okay? Common denominator. If you can get to this part, then you can just cancel them out. Just cancel them. You saw why it works, didn't you? So then what are you left with? 7x plus 10 equals a 15x plus 15. And that big, ugly fraction's gone, isn't it? That big, ugly fraction's gone. Now all of a sudden, it's not so bad. I can do this. I'll learn that in Algebra 1, right? Okay, so solve. Minus 7x, minus 15, minus 15, right? So I'm solving. I'll get a negative 5 equals a 8x. Divide by 8, and I get x equals, if I divide by 8, I get x equals negative 5/8. Now, I said it couldn't be negative 1 or negative 2. Cool. That'll work, right? Oh boy, example 4 looks really hard. But, John, got anything to say?
This is actually an easier trick.
Yeah, hang on to that, okay?
Okay.
Yeah. Okay. Because I'm going to show that probably in example 4, okay? Yeah. Okay, so, example 4 looks horrible, doesn't it? Right? You're just going to multiply that all the way up, aren't you?
I don't want to do it.
No, actually, I just put the x plus 2 the other side.
Yeah.
Is this one going to be on the test, the last one?
Yeah. Let's do this one. It looks horrible, doesn't it? So the first thing I'm going to do is I really am going to factor first. And there's a reason I'm going to factor. I'm going to factor right here. And the reason I'm going to factor is I can see how it's going to make these get close, right, if I factor. So let me write this. I'm going to go 12 over x plus 4 minus 7 over x equals 22 times an x times an x plus 4, okay? Now, let's go to what John's trying to tell you, okay, to make this even easier, okay? You know that we're going to cancel them out, right? So what we got to do is this. What's my common denominator? X times x times x plus 4, right? Everybody agree? Thanks, Julia. Julia, you're totally right. So Julia's saying our common denominator here, CD, is x times x plus 4, okay? Now John's going to help us skip that even canceling step. So John knows that we're going to cancel the denominators, right? You guys agree? You saw that trick in the last time? Last time I made the common denominators, And right here, I cancel them. So let's not even do that trick. Let's just go straight to multiplying and getting rid. So what does this fraction here need? What's the first fraction need?
Multiply by x.
X over x, right? X over x, but we're going to cancel that out because eventually we're going to cancel out the denominator. Does that make sense? What does this fraction need?
X plus 4.
X plus 4, x plus 4, but we know we're going to cancel out our common denominator, right? And this already has it. That's a lot easier. Hopefully you're following it. Hopefully it makes sense. So now what are we left with? Well, a 12x minus a 7 times an x plus 4
Wait.
equals 22, because we canceled that one out too.
You can't.
So once we get the common denominator, you can get rid of it. I'll say it again. Once you get the common denominator, you can just get rid of it. Thanks, John. So let's see what we get. Let's go ahead and solve this. 12x. We'll get a minus 7x minus 28. Thanks, John, for being patient with me. And then, oh, let's see. That's got to be a 5x minus 28 equals 22, right? Plus 28 plus 28. 5x equals a 50, right?
It's usually really easy right after you get done with all that.
Yeah, once you get rid of that ugly fraction, it's not so bad. You guys agree? So the trick is to get rid of that fraction. And to get rid of the fraction is to get the common denominator, right? Everybody agree with that?
Yeah.
Okay, and then that's all I got. So